All right, we are trying to take this standard form equation and rewrite this thing in vertex form. Now, just because this is your first time seeing this, I'm going to tell you off the bat that if I were to rewrite this in vertex form, it's going to look something like this. So how do we get this standard form equation to look like something where it's a number chilling out on the outside, it's x plus or minus some value squared, minus something else just chilling out over here? Here's how we're going to do this. It's all about completing the square. Now, if you think back to our steps for completing the square, there were a few things that had to happen. The first thing was that the x squared coefficient had to equal 1. And then we had to add a number into the problem. But then also keep things balanced. Whoops, into the problem. And keep things balanced. So before, what we did was we added maybe a 9 to both sides, or like a 25 to both sides. To keep things balanced with these types of problems, we're going to do something different. We're going to add a number in and then immediately subtract it out. So I'm going to add a 9 and subtract a 9. Or add a 25 and subtract a 25. So it's balancing things out, but it will allow us to rewrite part of the problem so that it looks how we want it to look. So let's start with this part first. The x squared coefficient has to be 1. What I'm going to do is take this 2x squared minus 20x plus 48, and we're only actually going to focus on these first two terms. And you'll see why in a second, but the thing is, I need this x squared coefficient to equal 1, and that 2 is getting in my way. So I'm taking the 2 out, and that's going to leave me with x squared minus 10x, plus 48. Now we're getting a little closer. This is starting to look a little bit more like vertex form, but I don't want it to be x squared minus 10x. I want there just to be one kind of x and the quantity squared. So I'm going to focus all of my energy on this part right here, and I want to get this to be a perfect square trinomial. So I've got to complete the square here. So really, when I do this work for real, I don't usually write the step I just wrote up here. I usually write x squared minus 10x, and then I put a big fat blank in there, knowing that I have to complete the square. But I can't just add numbers in here willy-nilly. Like that, that's going to change the value of things. So what I do is close the parenthesis, subtract another number that'll balance this out, and then that 48, we're just carrying that around with us the entire time. So the next part is we're still focusing in here, and we're trying to make this a perfect square trinomial. And if you did your homework on that, then you know the number that's going to go here is going to be half of whatever this is squared. So that's going to be 25. And remember, that trick only works because this x squared coefficient is 1, which is why our first step was to pull out this 2. Now here's the deal. You might think to yourselves, hey, he just added 25. He's going to put a 25 here. But I'm not going to put a 25 here. Because I might have added 25 to this blank, but that 2 I had to pull out, it's actually making what I added twice as big. Like there is kind of I'm not going to actually do this distributive property, but this is what I actually added. I actually added 2 times 25, which is 50. So in this other blank, what I'm going to put is whatever number I had to put here, I'm going to multiply by the number out here, and that's going to go here. If you don't like that, I'll show you an alternative way to look at it, but I'll do it at the end of the video, so you don't have to watch it if you do like what I do there, just fine. Now, there's a lot of writing on the screen, so here's where you have to remind yourself that we're right now just focusing on, once we pull this lead coefficient out, this is just a completing the square problem right now, just completing the square. And completing the square is, again, just taking half of this value and squaring it. And then knowing that now this middle portion can be written as x minus 5 squared with that 2 there. And then, of course, once I combine these terms, which are like terms, I get the minus 2. So this is the vertex form of that formula that was given way up here. And the nice thing is now I do know that this is a parabola that would shift 5 to the right and down 2. So if I was asked to know where its vertex was, the vertex normally is at 0, 0. But if it goes 5 right, its x value is 5, and down 2, its y value is negative 2. Actually, I'm going to do the alternative form of this in a different video, so check that out if you want to. It's not going to look much different, but I'll pick it up from the part where I had 2x squared. Well, check out the other video and you'll see. Okay.